In this section, we're going to talk about interest. So let's start by learning what interest is. In this picture, we have a home and a bank, and we're going to talk about us being the home and the bank being a place where we can either take money out of or put money in. In this first example, we are borrowing $100 from the bank. Whenever you borrow money, you have to pay to borrow that money. So in this example, we're paying 12% on the amount that we're borrowing. Since we're borrowing a nice easy number like 100, we know that 12% is the same as $12. So when we borrow this $100, at the end of the time that we have to pay it back, we're going to have to pay $12. So we actually end up owing $112 when we borrow $100. So the $12 is called the interest. In our next example, the bank is actually going to be a place where we deposit money so that we can save our money. When we deposit money into the bank can then use it to loan it out to other people. So the bank's going to pay us to leave it in the bank. In this example, the bank is paying us 5% interest. So in this case, we're $100 in the bank and then it's 5% interest to leave it in the bank. And I used a nice easy number like 100, so we'd know that 5% of 100 is $5. So when we go to take that $100 out of the bank, we'll actually get $105 for leaving it in the bank and saving. That's why people save. So banks give loans and they're a place to save money. They're also businesses and they have to make money. So what they do is they're going to charge more interest for their loans than they do in giving interest for their savings. And that's how they make money. So I gave you the example of 12% is what they charged in the loan we took and 5% is what they gave us in the savings. So they're making a 7% profit. And that's how banks work. Now we have a formula that's going to help us figure out how much interest we would either pay or make whenever we are either taking out a loan or we are putting money in the bank for savings. And it's the same formula either way. The formula is interest equals principal times rate times time. So the interest is the amount of money the bank either gives us for leaving money in the bank or the amount we have to pay for borrowing. The principal is the initial amount of money we start with. So in both examples before, $100 was our principal. That's the amount we started with. The rate is the percent that we earn or the percent that we owe. So in the first example, 12% was our interest. In the second example, 5% was our interest. And then the time is how long the money is left in the bank. And you need to always write the time in terms of years. If it's for months, then you would put it over 12 and write a fraction over 12. So let's look at an example. I borrowed $2,000, so that's our principal, at 9%, that's our rate, for 4 years, that's our time. How much interest did I pay? So you just plug this in. The interest is going to equal 2,000 times 9% times 4 years. So remember that you can either use your percent key on your calculator or put in 0.09 for percent. And when you calculate that, you just get 720. Very easy. So I paid $720 in interest for borrowing $2,000 at 9% interest over the course of 4 years. In our next example, I borrowed $17,000 to purchase a car. And this is a typical price of a not very expensive new car. The interest rate was 5.75%, which is very realistic, and the loan was for 5 years, again, very realistic. How much interest did I pay for the car? What was the total price of the car after I included the cost of interest? So first start plugging in our information. 17,000 times 5.75%, I'm just moving the decimal over 2 places to change it to a decimal, times 5 years. So the interest ends up giving me $4,887.50. So notice how much interest I'm paying on that $17,000 loan since I don't have enough cash to pay for it up front. So that's how much interest I paid. And my total repayment is going to be the $17,000 plus the amount of interest, which will give me $21,887.50. So that's actually the amount we paid for this $17,000 car. So it's always better to pay for things with cash. Now, here's an example where we're actually putting money in a bank. So I invested $4,500 in a CD at the bank. A CD is a certificate of deposit. It's a type of savings at the bank. The interest rate was 2.5% and for 18 months. Now notice this is months, it's not years, so we need to put 18 over 12. How much interest did I earn on my investment? What was the total amount of money I took back out of the bank at the end of the 18 months? So we want to make sure we answer all these questions. We're going to start with I equals PRT and put our numbers in. 4,500 is the amount we started with, so that's our principal. Our rate is 2.5%. I'm just going to move my decimal 2 places to change that to a decimal. And instead of writing 18, because it's not 18 years, I need to write it as 18 over 12 since it's 18 months. And I just plug that into my calculator. So my interest is $168.75. So that's how much money I get for just leaving my money in the bank. So that's the interest. And then I get a total of $4,668.75 at the end of 1.5 years or 18 months. So those are a few more examples of simple interest. And I want to talk about compound interest. Compound interest is when the bank charges interest frequently, adding the interest to the principal, and then charges interest again on the new principal. And this will make more sense once you see the math. It causes the total to increase faster, which is wonderful for savings, but not so great for debt. And it's one way that people get into really bad debt. With compound interest problems, you will see the word compound and how frequently the calculations happen or are compounded. This is the T in the formula I equals PRT. You will also be given an entire duration of the loan or savings. You use the entire duration to determine how many times to calculate the interest. So this will make more sense with some numbers. So let's first try to figure out what the T or time would be in each example and how many times you would perform the calculation. So if I have $500 compounded monthly for 6 months, that means our T is going to be the monthly. So that would be 1 over 12. And we're going to do it for 6 months, so we would do it 6 times. $25,000 compounded every 2 months for 8 months. Our T is going to be 2 months. So that's 2/12. And we're going to do it for 8 months. So basically, you divide 8 by 2, and 4 is how many times you calculate. So 2/12 is your time, and you calculate 4 times. 6,000 compounded yearly for 5 years. So for compounding yearly, T equals 1, and if we're doing it for 5 years, then the T equaling 1, we would do 5 times. $10,000 compounded every 3 months for 18 months. 3 months, the time would be 3 out of 12. For 18 months, you basically divide 18 by 3 to see how many times you have to calculate it. So you get 3/12 for your T, because it was 3 months, and then 18 divided by 3 is 6, so you're going to calculate it 6 times. And then we're compounding every 9 months here, so T is going to be 9/12. Again, months, you put over 12, and we're going to do it for 3 years. So in this case, T is 9/12, and we're going to calculate 4 times. You can take the 3 years and see how many 9 months there are in 3 years. So let's do some examples. I used my credit card to charge a new high-def TV, a Wii, and a few other things over the past month. I have run up my total debt to $2,400, and my credit card company charges 12.85% interest compounded monthly. If I plan on paying this off in 2 months, how much will I owe? Well, let's see. If it's compounding monthly, our T is going to be 1 over 12. And if we have to pay it off in 2 months, our total duration is 2 months, so we're going to have to do it 2 times. So we're going to start with putting the I equals PRT. You still use the same formula, I equals PRT, and our principal is $2,400. Our rate is 12.85%, so I just moved my decimal 2 places, and my time is compounded monthly, so the T equals 1/12. And I get $25.70, that's my interest, and to see the amount I add my interest to the amount I started with. Now, this is going to become my new interest, or my new principal in month 2. So, I'm going to recalculate, but now the principal is $2425.70, the $2,425.70 that I found in the first step after the first month. That becomes my new principal. I'm going to multiply that by the same rate for 1 month again. I get another interest amount. I add that interest to the new principal, and it gives me the latest principal, $2,451.68. So that's how much I owe at the end of 2 months. So again, let's look at this. So you do a calculation over and over again using I equals PRT. The only thing that changes each time is your principal will increase. So you get a new principal by adding principal and interest together. Each time you do your calculation, and you bring that new principal down to the next calculation until you've done all the calculations you have to do. And this is why the interest builds faster. Then the amount of money that you either owe or that you are making will build faster. Let's look at another example. I invested $20,000 in a savings account at my bank, receiving 2.3% interest compounded every 6 months for 18 months. At the end of 18 months, how much money will I have invested? So our principal is $20,000. Our rate is 2.3%. We're compounding every 6 months, so T equals 6/12, and we're doing it for 18 months. Well, 18 months divided by 6 is 3, so we're going to have to do the calculation 3 times. So we're going to have to do I equals PRT 3 times. So we start by putting the $20,000, the interest rate, and the 6/12 in, and we get the interest is $230. We have to add the interest back to the principal to get a new principal. Now we're going to calculate again, but we're going to use this new principal. So you can see that this was the total in savings at the end of 6 months. Now we're using that new principal to figure out the total in savings at the end of 12 months. So our new interest is $232.65. We're going to add that to this principal that we carry on, and we have yet another principal. We're going to do the same process over again with new principal. Again, only the principal changes between each step. The rate and the 6/12, the time, those don't change. Only the principal changes. So we're going to calculate yet again to find the total in savings at the end of 18 months. And we find our interest, add that to the principal that we had brought down, and that'll give us our total principal. So again, when you're working with compound interest, you're going to have to basically use this simple interest formula multiple times. And the only thing that's tricky is remembering the difference between the time is how frequently you compound. The total duration helps you figure out how many times you have to use the simple interest formula. And the principal will change each time until you get the final amount that you either owe or that you